Hello everyone. In this video, we will learn to set up Splunk SIEM Home-Lab from scratch. I have tried to keep it more real-world setup. Once we are done with this home lab, we will go through different use cases with attack and incident response. This is an exclusive project from our HexCamp platform. To access the detailed guide and tons of use cases, you can check our HexCamp Pro plan as well. Now, without taking more time, let's get started with Splunk SIEM Home Lab video. All right, so this is our lovely Splunk SIEM Home Lab. This entire home lab is set up using VirtualBox, or this can be also set up with the VMware or Proxmox. Okay, so you can go with any one of them, and with either of the virtualization, you get an option to set up the network and bridge, which will take your machine in the LAN itself, or a NAT mode where you can create a separate network altogether. Okay, so entire network has been designed in such a way that your attacker machine and your network machine and all the different segments of the network, including SIEM solution, DMZ network, and applications, are in different network. Okay, so let's start with this Splunk server first. In the Splunk server, this Splunk itself, SIEM itself, has been installed on Ubuntu, and it's also fetching the Suricata logs. From where? From this firewall in between. Okay, this firewall has been deployed. Has been working. Has been actually segmenting the entire network. Okay, when the traffic comes from the internet, it is hitting to the firewall. In our case, we'll be using Pfsense. You can use any one of them, maybe Palo Alto, Checkpoint, or Cisco as well. Okay, so Suricata, we with the Pfsense, we get an option to integrate Suricata directly and their rules as well. So Splunk is installed on Ubuntu, and we also configure this firewall to send the logs to the Splunk. Okay, that we will learn in the following videos. And this is our DMZ environment where our web applications are installed. This means DMZ means these servers can be accessed directly from the internet. Okay, through the firewall, of course. And we have a Windows server and we have an Ubuntu server, and on both the servers we have Splunk Universal Forwarder installed, so that whatever the kind of attack we launch from this Kali machine, which will be like in our insider thread, where we'll have Metasploit already pre-built. So whenever we try to launch an attack on either of this machine, this will send a log or alert, I would say, to Splunk. Okay, and remember, you have to install Universal Forwarder, Splunk Universal Forwarder on both Windows and Ubuntu machine. Finally, these three servers, these are all enterprise applications. So we have Docker, Kubernetes, and Nginx, which is a proxy. So all this will be installed on another Ubuntu server, right? And this is how the entire design has been done. So we will learn to set up this entire home lab from scratch. We are going to learn to install Splunk. Very simple lab, but very, very important. Okay, so let's do this. Make sure you have a Ubuntu machine. Get a Ubuntu machine. Again, as I said earlier, you can have Ubuntu server 22.04. That's what I recommend. You can install on your VirtualBox or maybe VMware or maybe in the cloud. Okay. Once you have that, run apt update immediately. Okay. This might take some time. Perfect. It's done. All right, so let's first install this Splunk. I can copy this file, wget command. I have to format this, so I'll do that later. Do the right click. This will install the Splunk file on this Linux machine using wget. Okay, let's wait for a few seconds. Perfect. Do the ls and you can find the file here. Okay, let's extract the file dpkg minus I. This will extract the file. Hit enter. Perfect. So it's done now. Splunk has been installed on the machine. Let's start this Splunk. So we'll have to go to the opt Splunk and bin directory. This is where you will find Splunk file, And what we need is this Splunk executable, which is here. Perfect. So you can run by dot, I mean Splunk, type yes, y, and then enter the admin username. So I'll say admin. Let's enter the admin password. So let's enter a strong password maybe. Let's confirm the password. Perfect. It's done. You can see the Splunk has been started. It's wonderful. Now the only problem is it's currently be accessible locally from the machine. You see this 127.0.0.1. So even if I won't be accessed from my browser to this machine unless you are running on your local, you went like you have a Linux uh desktop experience. In that situation you maybe access it, but if you have a Ubuntu server, it would be difficult, and you can't allow the users to access your Splunk globally. So that's a challenge. In order to fix this, we have to bind the IP address. So to do that, first of all we need to make sure we stop the Splunk. Okay, so let's first stop the Splunk. All right, so now let's bind the IP address to 0.0.0.0.0 so that the Splunk server can be accessible from anywhere. Okay, so let's move to OPT Splunk and then etc. Perfect. Under this, we have to find a file. Sorry. Under this, we have to find Splunk launch file. This is the one, right? So let's launch Splunk launch.conf. Okay. And then we'll have to change the Splunk bind IP address. So let's search for Splunk bind. I think it's usually not there. So we'll have to add a line instead. Okay. So type Splunk bind IP, okay, equal to 0.0.0. Perfect. It's done. Let's close it. Perfect. Now let's first note down the IP address of this server so that we remember to access it. Perfect. This is the server IP address. Now let's go back to the same directory from where we can execute this Splunk. Okay. So, and that's slash opt slash Splunk slash bin. Hit enter, and then we can run the executable, which is Splunk start. Remember, this is an executable. That means this already exists. I have shown you, I believe, right? So you can find Splunk, this one, right? So we are just going to execute this with start command. Now, when you launch this, this will run on IP address 0.0.0.0, which is this, right? And create a rule to allow this because by default only port 22 is allowed on a default server. So we'll have to allow 8000 TCP. Perfect. Now it should work. Um, Perfect. Can you see this? Should work. Let's try with password I created. Awesome, isn't it?
Okay guys, in this video we are going to learn how to forward a Windows logs to the Splunk. We are going to do this via Universal Forwarder. Very first, what is Universal Forwarder? So it's a lightweight version of a Splunk which is used to collect and forward the data such as logs, metrics and events from a source machines, and it send it to the Splunk indexer or a heavy forwarder. So if you have a 50 Windows machine or Linux servers, and so that you can install this universal forwarder on each of this machine, or even you can put a dedicated server on which Splunk forwarder to be installed. This is going to send all the logs to the main Splunk server for indexing, where our analysis and dashboards are getting built. In this video, we are going to learn how to install this universal forwarder on this Windows machine. After that, it is going to send logs to the Splunk server. So let's begin with the installation part. First, you need to go to the splunk.com. Once you're able to log in, go to the trials and downloads. After going into the trials and downloads, you will get an option of universal forwarder. Click on start download. This is going to lead you to this where Splunk Universal Forwarder 10.0.1 is going to be installed. We are going to install it on the Windows 64-bit, so you can see these options where you can download this MSI file, or even you can get the wget link. After copying this link, you just have to put it in the PowerShell, and the Splunk forwarder will be installed on that. So let's download this, and it is going to start downloading this particular file, and we are going to run this on a Windows machine. So it is going to send the logs to the Splunk. Okay, I have already downloaded this, and as well, while installation, it may ask you to provide the information like what kind of log that you want to forward. So you have to pretty much check mark those boxes like application, security, system, because Windows logs are categorized under this kind of categories. You need to define that category, what logs to be forwarded to the Splunk. We are going to modify the inputs.conf file and output.conf file. So Splunk will receive those application, system, and the security related event. Okay, so that file is present under the C, where the Splunk forwarder are installed. Under the C, let's go to the program file. After the program file, go to the Splunk forwarder. So you can see the Splunk Universal Forwarder installation, where we can see etc. Under the etc, go to the system, and then system, that is a local, and under that you can see the inputs.conf file. In this file, we are going to add couple of line which will tell it that we are going to send application, system, and security related logs. So this is, I'm going to add, while host will be Windows AD and index will be main, because we are also having that Pfsense also to be a part of main. If you want to make it in different than Pfsense, you can change the main index as well. Windows event log will be security, system, and application. So this kind of three categories we are going to add it to forward it to the main Splunk server. Okay, pretty much done. Save it, close it. Now we have to define that what is our main Splunk server IP address. So under the output, you need to change it, because while the installation, it is even going to ask you to provide the main Splunk server IP address. At that time also you can provide, or later on you can even modify if your IP address got changed, or even you have any kind of issue. So you can verify this outputs.conf file, which is responsible to send and to define the actual Splunk IP address. So our Splunk IP address in my case 192.168.10.12, and this is going to forward the logs on a port number 9997. Okay, this port later on we need to configure as a receiving port on the main Splunk, okay. Save, close it. You need to restart this Splunk forwarder service. In order to restart these Splunk services, what you can do is you can go to this path, program file, Splunk Universal Forwarder bin. From the command prompt, run this command, and then splunk.exe restart. This is going to restart the universal forwarder services on this Windows machine, because we have made changes on the input.conf and output.conf. After this is going to be restarted, we need to define 9997 port under the main Splunk server to be as a receiving port. As you can see, this is stop its services. Now it is going to start. Let's quickly jump onto the main Splunk server. I'm going to log in this one. After logging in, go to setting, and then under the forwarding and receiving, click on this. We are going to configure a new port which is 9997. For Pfsense, if you remember, we have defined 514. For Windows machine to send this logs through the universal forwarder, we require to add this port 9997. Click on save. Perfect. So we added 514 and 9997 as a new port. Let's see if our services, Splunk Universal Forwarder services, has been restarted or not. So go to this. So it successfully stopped first, and then again this services has been started. In order to verify the status of it, if it is running or not, you can run the command splunk.exe status. I can see that it is running. So now let's see in the search and reporting in the main server if it is showing or not. Perfect. So we have defined index as main. Under that, you can see the host. We can even see that Windows AD now. Okay. And the source type is active. All these logs we can see even now from the Windows as well. So this is how you are going to set up a universal forwarder on a Windows machine to send the Windows logs to the main Splunk server. Thank you so much for watching this video. We are going to cover how to install universal forwarder on a Linux machine in the next video. Thank you so much. Welcome back, everyone. In this video, we are going to send the logs of Linux machine to the. If you remember the last video in which we have sent the logs of a Windows machine to the Splunk using Universal Forwarder. Again, what is Universal Forwarder? It is nothing but the collecting the logs of an agent and sending it to the main Splunk server. In this one, we are going to use the same Universal Forwarder to collect the logs of our Linux machines, and then it send it to the main Splunk server. Okay. In my lab, these are my current IP address. This is the main Splunk IP address. First of all, we are going to install the universal forwarder on this agent, a Linux agent, and then we are going to send those logs to the Splunk server. So let's get started. Again, you log in into the Splunk, and then once you successfully log in, go to trials and downloads. Click on the universal forwarder, start download. You will see an option of Windows, Linux, Mac OS. So we are going to click on Linux machine, where we are going with the 64-bit because it's my Ubuntu machine that I have installed 24.04. And so we are going to go with the Debian. Okay. Go to the copy wget link so you can see this link information. Copy this, go to your Linux box, paste it. This is going to download the Splunk forwarder 10.0.1 on this one, and after that we are going to install it. Perfect. So this has been downloaded. Now the next step is installation. So we are going to depackage this installation file that we have just downloaded, and after that we are going to run again the following step. Okay, I can see the one that I have downloaded today, Splunk forwarder 10.0.1. So let's depackage this file in order to install this. So command is dpackage -i. Once you run the command, it is going to start unpacking this. I mean, it is going to start the installation. Okay, as you can see, our installation has been completed. Now the next process is to start and accept the license. So you can run this command, and we can create the credentials after accepting the license. Okay, here run this command to accept the license. So the next process is to set this machine to forward the logs to the main Splunk server IP address. So we are going to add this command where you can see you have to define Splunk server IP address here, which is going to receive the logs over the port number 9997. And again, you have to provide a credential of your main Splunk here. In my case, the Splunk server IP address is 10.12, so I'm going to change it to the main Splunk IP address as 10.12. I'm going to put the credential for the admin user for the main Splunk server. Let's copy this, and okay. So here the main Splunk server IP address is going to be changed to 192.168.10.12, and I'm going to put the credential for the admin user. After that, you are going to see the successful message that forwarding has been enabled. Now we need to add some of the path like auth, syslog. These are going to be added to be monitored under this Splunk. So we are going to tell Splunk forwarder what kind of log files that need to be monitored via Splunk. So I'm going to add auth log. So let's copy this and add it. Okay. It added the monitor of var log auth.log. Now let's go main Splunk. Once you successfully log in, it's time to configure the receiving port 9997. Last time we have seen that we have already enabled for the Windows machine. So pretty much you can go to this setting and then forwarding and indexing. Configure the receiving. We have already added for the Windows machine 9997. So if you have not enabled, so you can click on new receiving port and then you can add it 9997 ports. Perfect. After I search with the index main, you can see the one more host has been added. The first one was the Pfsense we added. Second one, we have added Windows machine, and now we can see the Ubuntu agent as well. So it has started collecting the logs from the Ubuntu agent. So we have successfully configured a Splunk forwarder on the Ubuntu machine to send the logs to the main Splunk server IP address. As you can see, the auth log that we have set to be monitored in the Ubuntu machine. So we can see those all events like 1586 events so far from that Ubuntu machine. Thank you so much for watching this video. See you in the next. Hello everyone. In this video, we are going to install Pfsense firewall for our home lab. This firewall is set to be configured as a security appliance for our home lab. So let's begin. First of all, you go to its official website pfsense.org. Under the download section, you need to click on this download. It will definitely ask you to sign up if you have not already signed up for this. Once you sign this up, it will ask you to select an installation image. So you need to select the AMD 64 ISO or the virtual machine, and that need to be added to the cart. After that's pretty much you need to check out for this, and it will lead you to the ISO image file. You need to provide all this information, and after that it will show you the option of downloading that ISO image. I have already downloaded that image, so let's begin the installation part. I am going to show you how to configure the Pfsense on an Oracle VirtualBox. Once you open the VirtualBox, okay, click on new, then provide the name of this VM Pfsense, okay, and the ISO image that you have downloaded, that you need to select it from here. This is the ISO image file. This is the version that I have downloaded, 2.7.2. Open, and then OS you can select as a BSD 64 bit. We are going to specify the hardware requirement, so at least I am going to allocate at least 3 GB for this one, and the number of CPU will be, I'm going to allocate as a 2. Okay, so I'm going to verify all the information that I put it, like the name, operating system, the base memory, processor, and the file that we have selected as a ISO. As per our topology, we have three interfaces to be configured for a Pfsense. The first will be your bridge network. So I'm going to select this as a bridge adapter so it can talk to the internet. Okay, and the adapter 2 will be our NAT network. Second, the LAN DMZ is nothing but I have defined it for interface which is going towards the Splunk Windows machines, and the adapter 3 will be our Kali side. So I'm going to select that network as a Kali. This is the interface which is going towards this Kali machine, which will be acting as an attacker. It will be completely different network than a bridge and the NAT network. Okay, so three interface that we have selected: adapter 1, 2 and 3, and I'm going to hit OK. So we are good with the networking, storage, and the system specification. Let's start it. Hit enter key to accept, and we are going to install this. So install pfsen, hit enter to OK. We are going to select this option as it is, so hit OK. Proceed with the installation, hit OK. We have to check this interface, so you can use spacebar to select this and then hit OK. It is asking, are you sure to install this? So yes, this is going to start the installation process for the Pfsense firewall. Pretty much our installation has been completed. We are going to reboot this machine, and once the IP address will be assigned via DSCP, we are going to access this machine from the web browser. Once the installation will be completed, go to the storage and remove this ISO. First, I'm going to shut down this machine. Once it is going to shut down, then pretty much go to the setting, go to the storage, and we are going to remove this ISO file. So click on this remove attachment, remove, and hit OK. Let's start it again. So now it is initializing the device manager and configuring the LAN and WAN interface. You can see that the IP address 1.7 to the WAN and 1.1 to the LAN. Okay, based on our requirement, we are going to even change it as well, and we can even set the interface IP address, like the options here, like number 2 to set interface IP address, we can assign the IP address, and then we can assign the interface. So currently my local machine is a part of the WAN interface. I mean, we have put the bridge interface, and by default Pfsense block all inbound WAN access including the web UI as well. So we can temporarily disable the firewall filter in order to access this from our local computer. Later on we can enable it, and then we can access it through our Windows endpoint, which will be a part of LAN network. So I'm going to go in the shell, which is the number 8. Go and then run the command pfctl-d. This is going to disable the packet filter completely. So all traffic is now allowed on the WAN interface, including the web access. So from which you can access the web UI. And another option is to access pfSense via LAN interface. Okay, so LAN interface is actually configured as a 1.1, is a DMZ network in which all Splunk endpoints are exist. So this segment is under the 192.168.10.0/24 network, and from that I am going to assign the IP address to this pfSense, I mean LAN interface, as 192.168.10.7. This will be my IP address on the LAN segment side. So in order to assign this IP address, you can go to again option number 2, assign the IP address. Okay, which interface you want to assign. So you can select number 2, enter, because we are configuring LAN interface. Do you want to configure LAN interface via DSCP? I am going to select no. Enter the new LAN IPv4 address. So my IP address is 192.168.10.7. It is asking me to provide a subnet mask which is 24. Okay, and even it is asking for a default gateway. I'm going to put that as it is. So enter, and then IPv6 address, press no. New LAN IPv6 address, hit enter. Again no. Do you want to revert? No. So this is going to apply the changes. So we got the new IP address as 192.168.10.7, through which we can access the web UI of our pfSense. So here we go with the HTTPS 192.168.10.7, through which I am able to access this pfSense firewall. It is highly recommended first you install the Windows machine, which is a part of our LAN segment. So from that, you can access this machine on a LAN environment. So by default, username and password for this admin, and the password is pfSense. Okay. Once you log in into the device, you need to change the password. Once you successfully log in, it will ask you to change the password for the admin user, so you can change it immediately. I already changed the credential. Pretty much you can see the interface as well. WAN, LAN, and the option one. This option one is nothing but the our Kali side network. LAN is our where the Windows machine Splunk are hosted, and the WAN is towards the internet side. Okay. We required a Suricata to be installed on this pfSense, which will be acting as a network IDS in our home lab. Go to the package manager. It will show you the available package, in which type Suricata, search it, search for the Suricata. Once you get the package, just you need to install them. I have already installed it. I can see that under the installed package, the Suricata. Once you install this, it's time to run this Suricata services on an interface on which we need it. We need this Suricata to be enabled on a WAN interface and the Kali side interface. So go to service and then Suricata, where you need to define the interface on which Suricata to be enabled. I have already added those interface on which the Suricata will run as a network IDS, and any kind of threats, if it is detecting, it will be logged under the firewall event. Okay, so this is how you are going to set up a pfSense firewall for our home lab. In the next video, we are going to see how to forward the logs to the Splunk. Thank you so much. See you in the next video. Hello everyone. In this video, we are going to learn how to send Pfsense logs to the Splunk. Okay. First of all, once you log in into the Pfsense, go to the status, system log, and then under the setting, scroll down little bit at the bottom where you will be able to see the enable remote logging. Now click on this. After that, you have to define the source address will be a default, and the remote log server. We are going to send this logs to the Splunk. So you need to define your Splunk IP address. By default, it is sending these logs on a UDP port number 514. If you have multiple remote syslog servers, even you can define their IP address in this field. Okay. Once you configure this, let's check this box: systems, events, and the firewall events. So these are the events is going to be sent from this pfSense to this Splunk. Let's save it. So with this, pfSense systems and firewall logs will be forwarded to the Splunk. This is what you need to the pfSense. Now next is to send a event log to the Splunk via syslog. Go to services and then Suricata and select the interface. Click on this, add it. You will see the option of logging setting. In this one, what you need to do is keep all this option as it is, and you need to click on this output setting as JSON log. Click on this, and then our output type should be the syslog. So instead of file, make it syslog. Facility as syslog, and this is I'm going to put it as it is notice. Pretty much we are good with it, here. All other settings should be keep as it is. Click on save. Now our pfSense is ready to send the logs to the Splunk. Now it's time for Splunk to receive these logs. Once you log in into the Splunk dashboard, go to this setting and then forwarding and receiving. We are going to receive this log from the pfSense, so we need to define on the receiving port should be the 514. Under the receive data, click on configure receiving. Okay, I already added the port number 514. How to add this? Click on new receiving port, and you need to define the port number 514 and hit save button. So this is going to receive the logs over the port number 514 because we have set the pfSense to send these logs over the port number 514. Now the last thing is to configure the inputs.conf file. This file is one of the Splunk core configuration file that tells Splunk what data to ingest from where and how to tag it, like source type, index, host, and etc. This is actually present in the directory opt splunk etc system local, okay, where you can find this inputs.conf file. So we are going to define from where the data will come, how the data will be broken, and where the data is going to be stored, right? So I have already made the configuration to define this file. So here is the content of this file. The first line, which is host pfSense, which set the source host name for all logs arriving on the port number 514. The second line, connection underscore host is equal to IP address. This will show you the IP address in the host field, that from where the data is coming from. And next is your source type is equal to syslog, which keep the correct syslog type so Splunk can parse it properly. And index is equal to main, which will be still be indexed under the main, which is an existing index. If you want to modify it like a Suricata or anything, you can even modify it later on. This is what you need to define the inputs.conf file. After you make your changes, you need to save and restart the Splunk. So command is sudo opt splunk bin and the Splunk restart. This is going to restart the Splunk because we made the changes on the inputs.conf file. After the Splunk restarted, it's time to re-log in again and verify if it is receiving the logs or not. So according to our inputs.conf file, our index is equal to main. So I'm going to put this. So I'm going to search with index is equal to main. Perfect. Now this Splunk is receiving the logs from pfSense, where you can find the host is equal to our IP address of our Pfsense, source type is syslog, and all the data according to the syslog Splunk has already passed, and it has given some of the interesting field like index. This is how we are going to send a logs of a Pfsense to this Splunk. Thank you so much for watching this video. See you in the next.